Hello, my name is Matt Tones. I'm a senior application engineer at Garlock Sealing Technologies, and today's webinar is going to focus on a new product called GYLON EPIX. It's our next generation in PTFE gasketing materials, and we will basically focus on some of the features and attributes of the materials, as well as some other information specific to the performance characteristics of the material. So before we get started in that direction, though, we would like to take a little bit of time to talk about some of the background. We did extensive research to find out the common issues seen by customers in the field in order to design the product to resolve some of those issues for customers. One of the biggest misconceptions that we encounter when talking with engineers and reliability engineers in the field is that thicker gaskets are better when used in flat surfaces. But in reality, adding a thicker gasket to a flange connection makes the gasket's pressure resistance drop drastically. Typically, when we think about pressure in a pipeline, it's typically expressed in PSI, or pounds per square inch. So the thicker a gasket is, at the ID of the gasket, you're exposing more square inches of the material to the system pressure. So having thicker gaskets creates more outward force on the gasket, which has a tendency to lower the pressure resistance. So typically, if you find gasketing used today in the field, you'll find that they're usually a 1/16 or 1/8 inch thick gaskets. And for the most part, they both have their pros and their cons depending on the application and the conditions they're being exposed to. So 16th inch gaskets are typically used where flanges are in good working condition. So surfaces are clean, surfaces are in good working order, not a lot of rust, not a lot of damage. A lot of times your 1/8 inch thick gaskets are going to be used where surface conditions are maybe not as good, may have some pitting, scratches, or defects in the flange faces. So the 16th inch material, if we look at it from the performance perspective, the pros are 16th inch gaskets have better sealability characteristics, and because you have less material between the two flange faces, you have better load retention characteristics than the thicker material. The cons are, with the 16th inch material, your material is fairly thin, and therefore it's a little bit more difficult at times to get a seal if your surfaces are less than ideal. With the 1/8 inch thick gasketing material, those are commonly used in surfaces that are less than ideal, maybe damaged, pitted, worn, scratched. They can also be surfaces that are not completely flat. So typically in a large diameter flange, say anything over 10 inches in diameter, it's very common to use a 1/8 inch thick gasket because the flatness can be somewhat an issue because of welding and other bonding operations to connect the flange to the pipe. But the downside of those thicker gaskets is more material you put between a surface, the more relaxation you're going to see long term. So bolt load retention is not quite as good for 1/8 inch thick materials. And also, as previously discussed, using a thicker gasket, you're exposing the gasket to more outward forces and reducing the blowout resistance. So one of the features that we talked about previously was the bolt load retention. One of the tests that we did on the EPIX material was called the DIN 52913, which is a high load, high temperature load retention test that's used in the European marketplace. And in that test, basically you're exposing the gaskets to an assembly stress of 7250 PSI at 500 degrees for 16 hours. And you can see from the numbers shown here, the traditional legacy material 1/16 inch GYLON 3500 at 46.6% load retention. The 1/8 inch 3500 GYLON was at 45.3%, and the new EPIX material was at 52.2% load retention. So there's a pretty significant increase in load retention. And what does load retention mean to you as the customer? It means the gasket in the flange assembly is going to stay tighter longer. And as you can see from the numbers below, we saw similar improved load retention for all styles that were tested. The other test that we did was how well does this gasket going to work with surfaces that are less than ideal. So what we did in our lab environment was we created two damaged surfaces. One was a 10,000 thick scratch, one with the 20,000 thick scratch. And we used these platens to do permeability or sealability testing. And what we found with the 10,000 thick groove, on the left-hand side, you can see the traditional 1/8" 3500. Again, 1/8 is typically used for damaged surfaces. The new EPIX material, 3500 EPIX material, sealed significantly better than the traditional product. And then on the far right, 3510, same thing. The new EPIX material sealed significantly better. With the blue GYLON material, if you're familiar with the traditional legacy GYLON materials, 3504 is a very soft material to begin with, so we had very similar performance from that product. With the even deeper groove, so instead of 10,000s, we took it up to 20,000 thick deep groove. Again, there was a significant improvement in sealability characteristics because the hexagonal pattern on the new EPIX material significantly increases the compressibility properties of the product. So traditional 3500 has a compressibility of about 7 to 12%. The new 3500 EPIX material's compressibility is over 40%. Similar with 3510 material and the 3504 as well. So your compressibility equates to ability to conform to surfaces that are less than ideal. When it comes to gasket widths, one of the common questions we have is how thin can we go with the gasket cross section? The general rule that we use in application engineering for all gaskets is minimum gasket cross section should be no less than 1/2 inch. Now, there are many applications in the field where they are less than 1/2 inch. What we find is when you go less than 1/2 inch cross section on a gasket, you start to see more permeation or leak rates past or around the gasketing materials. So it's very important if you do encounter something where the surfaces are less than 1/2 inch wide, consult with the Garlock application engineering just to make sure that the product is going to be suitable for the conditions. So a little bit of a summary on the features or the benefits associated with the new GYLON EPIX material. First and foremost is it gives you the ability to consolidate the number of thicknesses you're using in a facility. We've talked to many end users that have that really piques their interest. It's the ability to have one thickness gasket and not have to ask the question, should I go with 16th or should I go with 8? It also helps them reduce their inventory. Now having one, if a end user, for instance, has material on the shelf to cut gaskets as needed for shutdowns or other situations, they only need one sheet of material now to cover 2 different thicknesses of material. The error portion of it is, again, somebody working on maybe a second or a third shift when the support staff is not available, or maybe the supervision is not available. It eliminates the error associated with, did I use the wrong thickness for the application? Improved compressibility over 16th, as I mentioned earlier. Especially for 3500 and 3510 in particular, your compressibility is in the neighborhood of 10 to 20 times higher than the traditional products, which gives you much more ability to handle misalignment, worn pitted flanges, because the product is much more forgiving. It also provides the improved sealability and blowout resistance over the 1/8 inch gasket. Again, we have less exposure at the ID, which means less outward force, which is better pressure resistance. And thinner materials typically seal much better as well. We also have the ability to seal in some non-metallic piping systems, which we'll go into a little more detail here in the next slide. And we've also had some success with it in other non-metallic surfaces like high-density polyethylene. So that concludes our webinar for today. If you do have any questions about what was presented, you can feel free to call me. My name again is Matt Tones. I'm a Senior Application Engineer at Garlock Sealing Technologies. Our 1-800 number is shown on the screen. You can also contact the Garlock Technical Support Line at 315-597-7350. And I thank you and have a good day. Bye-bye.